Okay, so you want to build an empire refining gold from electronic components. You picture a flawlessly automated assembly line, shipping containers unloading obsolete servers, vats of acid bubbling away, culminating in the euphoric pour of a shining 99.99% pure 1 kilogram gold bar. Looking at this surface picture, anyone would think this enterprise is quite literally minting money crap. Goes in, bullion comes out, just scale up the company and get rich. The problem is, you are looking at the most deceitful 60 seconds of this entire business model. The truth is, e-waste refining is not a precious metals business. It is a ruthless, hazardous waste and logistics engine temporarily dressed up as modern-day alchemy. And I am going to tear down your entire cash flow right now to show you exactly where your margins go to die. First, let us look at the illusion of your unit economics, starting with the math you did on a napkin. It always looks magnificent on the napkin. You decide to run a standard mid-scale batch, acquiring 10,000 pounds, or exactly 5 metric tons, of mid-grade telecom and server boards. In the e-waste brokerage market, decent mid-grade boards trade at roughly $4.50 per pound, meaning your initial capital expenditure just to secure the raw inventory is exactly $45,000. You consult the historical yield charts and see that telecom boards typically yield around 200 grams of gold per metric ton. You have roughly 4.5 metric tons of actual board material after stripping the packaging, bringing your expected yield to a beautiful 900 grams of gold. With the spot price of gold sitting at a highly favorable $75 per gram, your expected gross revenue is $67,500. You look at that equation and smile. You just spent $45,000 to make $67,500, yielding a gross profit of $22,500. That is a 33% margin just for dissolving old computers in a bucket. You calculate that you can run 4 of these batches a month, and you are already shopping for a Porsche. Now, let's wake up and run the real numbers. Next, you run headfirst into the brutal reality of chemical processing, where your acid costs will completely eviscerate your paper profits. Gold does not sit isolated on a circuit board waiting for you to gently wash it off. It is electroplated over a barrier layer of nickel, which is plated over heavy copper, which is embedded in thick layers of woven fiberglass, epoxy resin, steel brackets, and lead tin solder. To get the gold, you must first defeat these base metals. You cannot simply dump motherboards into aqua regia, a potent mixture of hydrochloric and nitric acid. If you do, the nitric acid will attack the copper and the tin first, and copper is voracious. It will consume your expensive acid at an astonishing, mathematically terrifying rate. A standard motherboard is up to 20% copper by weight. In your 10,000-pound batch, you have 2,000 pounds of copper. To strip these base metals properly before extracting the gold, you must use a nitric acid wash. It takes approximately 3.8 liters of industrial-grade nitric acid to dissolve just 1 kilogram of copper. Let's do the math. 2,000 pounds is roughly 900 kilograms. Multiply that 900 kilograms by 3.8 liters, and you need a staggering 3,420 liters of nitric acid. Industrial nitric acid at 68% concentration costs about $4.50 per liter when bought in bulk, 275-gallon totes. The chemical toll, just to remove the copper, is $15,390. To get the base metals out of the way, your $22,500 paper profit just plummeted to $7,110. And you haven't even dissolved the gold yet, nor paid your rent, nor paid your electricity, nor paid your labor. You are paying industrial chemical rates to dissolve a base metal worth $4 a pound just to access a microscopic flake of a metal worth $75 a gram. This is the fundamental, inescapable thermodynamic flaw of your business model. Then, the nightmare deepens as you open the toxic ledger and face environmental extortion. You just dissolved 900 kilograms of copper, nickel, lead, and tin into 3,400 liters of acid. You now possess roughly 4,000 liters of highly acidic, heavy metal-loaded toxic sludge. You cannot pour this down the drain. If you do, the environmental protection agencies will raid your facility, confiscate your assets, and put you in a federal cell. You must dispose of this legally. Hazardous waste management companies charge by the 55-gallon drum, and 4,000 liters is exactly 19 drums. The current market rate for treating and disposing of highly acidic, heavy metal liquid waste is roughly $650 per drum. Multiply 19 drums by $650, and you get a bill for $12,350. Look back at your profit and loss statement. Your remaining gross profit was $7,110. Subtract the $12,350 for waste disposal, and you are now operating at a net loss of negative $5,240. You are literally paying for the privilege of working in a dangerous, toxic environment, and we haven't even factored in the air you breathe. When nitric acid attacks base metals, it produces nitrogen dioxide. It is a dense, terrifyingly beautiful orange gas, and it is absolutely deadly. Inhalation turns the gas back into nitric acid inside the moisture of your lungs. To survive, you must install industrial fume hoods, run negative air pressure inside the facility, and push the exhaust through a massive wet scrubber system that uses caustic soda to neutralize the acid gas before it hits the atmosphere. The caustic soda, water pumps, and scrubber maintenance per batch will run you another $1,200. Your net loss is now negative $6,440. After that, let's pretend you are a logistical genius. Let's pretend you found a cheaper source of black market acid, and you pre-sorted the boards perfectly to mechanically remove 80% of the copper. You optimize the flow, and you are miraculously back in the green. But then, you begin to bleed out silently through human labor, physical shrinkage, and the unavoidable laws of chemistry. The labor illusion. You need human beings to depopulate the boards, shearing off aluminum heat sinks, unscrewing steel brackets, and popping out high-grade ceramic processors. This is brutal, tedious, manual labor that results in fiberglass splinters and repetitive strain injuries. 3 workers, making $20 an hour, working 8-hour days for 2 weeks just to prep your 5-ton batch, will cost you exactly $4,800. The shrinkage. Your workers know what is valuable. A vintage ceramic CPU contains up to a full gram of gold and fits perfectly into a pocket. A handful of heavy gold-fingered ram sticks disappears into a lunchbox. In this industry, a 2% material theft rate is considered a tightly run operation. 2% of your 900-gram yield is 18 grams, which equals $1,350 lost straight to the employee parking lot. The chemical yield loss. Chemistry on a chalkboard is perfect, but chemistry in a 500-gallon vat is messy. When you drop the dissolved gold out of the aqua regia using sodium metabisulfite, it does not all clump neatly into a heavy brown powder at the bottom. Some of it forms colloidal gold microscopic particles suspended in the liquid that refuse to settle, turning the liquid a slight purple. That purple hue is your profit margin floating away. When you wash the gold powder with distilled water and hydrochloric acid to clean out the lead, you lose a tiny fraction of a percent with every single decant. Standard operational yield loss in mid-scale e-waste refining is 5%. 5% of 900 grams is 45 grams, meaning another $3,375 is lost to the drain and the filter papers. The assayer toll. You finally melt your remaining powder into a beautiful, glowing bar and take it to a major bullion dealer. They do not hand you spot price. They drill it, assay it with an XRF gun, and find it is 98.5% pure, not 99.99%. They charge you a $150 melting fee, and they take a 3% refining toll to bring it up to LBMA standard. That is another $2,100 stripped from your revenue. Finally, the ultimate killer steps in, the working capital chokehold. The pacing of this business will break you long before the chemicals do. You buy the boards, sending $45,000 cash out the door immediately because e-waste brokers do not offer net 3-0 payment terms to small refining enterprises. You shred the boards. The dust settles. The manual labor takes 14 agonizing days. The acid pours, the orange fumes rise, and the scrubber screams for 5 days of careful batching. You filter, precipitate, and wait 48 hours for the powder to settle. You wash, dry, and melt. You ship to the assayer and wait another 5 days for the wire transfer to clear. Your $45,000 in raw materials, plus your $20,000 in operating and chemical expenses, is locked up and completely unavailable for a minimum of 28 to 35 days. What happens if the shipping container you bought was salted? What if the broker stacked high-grade telecom boards at the back of the pallet for inspection, but filled the middle with completely useless, gold-free CRT monitor boards and heavy steel power supplies? Your expected yield drops from 200 grams a ton down to a pitiful 80 grams a ton. You still have to process the entire batch. You pay the exact same amount in labor, the exact same amount in acid, and the exact same amount in hazardous waste disposal. But your revenue just got slashed by 60%. You do not just lose your profit margin, you lose your core working capital. You cannot afford to buy the next container. You cannot pay your hazmat crew. You default on your industrial lease. In this game, it only takes one single bad batch to wipe you off the map entirely. The revenue chart of an e-waste gold enterprise looks exactly like the heart monitor of a dying man. Wild, violent spikes of cash influx followed by agonizing, extended periods of brutal cash burn. If you step back and look at the fully operational P&L, you realize a terrifying truth. The margin does not come from the gold. The gold is a fixed commodity. Its price set in London and New York, leaving you with zero pricing power. The acids are fixed industrial commodities where you have zero pricing power. The hazardous waste regulations are fixed by the government, giving you zero negotiating power. So, who actually survives in this industry? Who actually gets rich? It is not the best chemist, and it is not the guy with the most expensive induction furnace. The single ultimate factor that determines who survives and who goes bankrupt is supply chain and mechanical sorting supremacy. The winners are the hyper-pragmatists who build massive upstream networks to buy raw e-waste for absolute pennies on the dollar. They are the operators who ruthlessly separate the copper, the steel, and the aluminum mechanically, long before a single drop of acid is ever poured. And they sell those bulk base metals to traditional scrap yards, just to subsidize their operational costs. They limit their chemical processing exclusively to the highest yield, most heavily concentrated components, the CPU pins, the RAM fingers, the integrated circuit chips. Everyone else? The hobbyists trying to scale up? The dreamers intoxicated by the idea of pulling treasure from trash? They do not become gold tycoons. They become unpaid janitors for the global tech industry, slowly going bankrupt in a cloud of orange nitrogen dioxide, paying industrial waste companies to haul away the dissolved remnants of their own capital.